Okay, here's our second video on adding and subtracting the rational expressions. Remember, when you are adding and subtracting, you need a common denominator. So let's take a look at our denominators. So the one thing that we haven't had to do yet, if your denominator can be factored at all, it's so much easier to get a common denominator if we see this in factored form. We want to see this in factored form. So I'm going to go ahead and rewrite the problem. T squared plus t, you can factor a t out, leaving you with a t plus 1. Plus 1 over t squared minus t, you can factor a t out, and it leaves you with t minus 1. Alright, so if you look at the problem we're adding, I can see we already have a common denominator of t. So that's set. I notice this one has a t plus 1, this one does not have a t plus 1. So we're going to go ahead and multiply in a t plus 1 on the top and bottom. Alright, now this one has a t minus 1 that we do not have over here, so I'm going to go ahead and multiply that one in over here. T minus 1 on the top and bottom. And then we rewrite our problem. I know that the denominator is t plus 1, t minus 1. And then the numerator, we're just going to multiply t minus 1 times that 1, which is just a t minus 1, plus this denominator is t plus 1, t minus 1. So we've got that common denominator. And then we'll go ahead and multiply up there. 1 times t plus 1 is just a t plus 1. Alright, so now when we add our fractions together, we have a common denominator, so I already know that that's going to be a t plus 1, t minus 1. And then we're going to add these numerators right here. So I have, it's easier with addition because you don't have to distribute a negative, but we have a t, I'm just going to rewrite it anyway, t minus 1 plus a t and plus a 1. Alright, so now let's simplify the numerator. I can see that we have a t plus a t, which gives you 2t. Negative 1 plus 1 is going to cancel out, so we have 2t over t times t plus 1, t minus 1. Alright, so now this is our answer unless we can do any simplifying. We're looking to cancel anything on the top with anything on the bottom. T plus 1 and t minus 1 can only be factored with t plus 1 and t minus 1. So, do we have anything else that can cancel? So this t right here is going to cancel with that t right there. Final answer is going to be 2 over t plus 1, t minus 1. Alright, here's our last example. Similar to the last one, when you are adding or subtracting fractions, you want that common denominator, but we want our denominators in factored form just so that it's easier to tell what we need in order to make them common. So I'm going to rewrite this problem. X squared minus 1, that's your difference of squares. That factors into an x plus 1, x minus 1. Minus 1 over, well, x minus 1 squared just tells me that there's two of those. X minus 1, x minus 1. Alright, so now let's take a look. We have an x minus 1 here and an x minus 1 there. I have an x plus 1, so I need the x plus 1 over here. Remember, multiply it to the top and the bottom. Alright, so are the denominators the same yet? Well, no, this one has an extra x minus 1 that we're missing over here. So I'm going to go ahead and multiply in an x minus 1. And now we have the same denominators, but I'm going to rewrite the problem. We have an x plus 1, an x minus 1, and another x minus 1. In the numerator, we'll multiply that out. We just have 1 times x minus 1, which is x minus 1, minus, now this one, we got that same denominator, x plus 1, x minus 1, and another x minus 1, and then just 1 times x plus 1, which is x plus 1. Alright, so we have the same denominator. So when we do the subtraction, I know that our denominator is going to be x plus 1, x minus 1, x minus 1. And our numerator is going to be all of this right here. But careful with that subtraction. We've got the x minus 1 from the left, and then we're going to subtract an x, so minus x. We're going to subtract the 1 minus 1. So in that numerator, we see that we have an x minus an x, so those cancel. But we have a negative 1 minus a 1, which gives us negative 2 over x plus 1, x minus 1, x minus 1. And then, just because this is our final answer, we've got that double x minus 1s. I left those separate throughout the problem just in case something would have canceled in this step, but nothing did. So for our final answer, we can just say we have a negative 2 on top. On the denominator, we have an x plus 1, and then we have an x minus 1 squared, because we did have 2 of those. And that one's done.